Hi, today we're looking at this LeetCode medium problem 45 jump game 2. You are given a zero index array of integer nums of length n. You are initially positioned at num0. Each element nums I represent the maximum length of a forward jump from index I. In other words, if you are at nums I, you can jump to any nums I plus j, where uh, j is between 0 and num's length, and I plus j is less than n. Return the minimum number of jumps to reach n minus 1. The test cases are generated such that you can reach n minus 1. Okay, so this kind of guarantees we're going to reach. So let's define our variable jump is equal to 0. So it's going to return jump. Then we need a loop. So let I is equal to 0, I less than nums uh, length minus 1, I plus plus. Then we need some kind of logic here to basically increment jump. We also need a variable max, and so we could say max is equal to math dot max. Then we say max and max over I plus nums I. We do I plus S, so basically, so if we have this here, and if we have I is over here, so I plus. So if you move I here, so the index is going to be 0 plus 2, so 2 is going to be here, but if I is over here, it's going to be 1 plus 3, so that's going to end up here. So that's why we got the plus 1 here, and so basically that's the basic structure of it. We need a mechanism to so the basic idea is we have an array, and we have the max variable, which at the moment is at 0, but the logic is for that one is something similar to this, like it's just a mathematical calculation, and I basically going to go through the array, and we can add another variable current max. That's going to be at 0, and the idea for current max is that current max is going to move along calculating the current max, and so at current max I, from I the current we can go. So if you come in the first time, if you're at I, and current max is 2, so current max can be basically over here, and so we will say I, if I is equal to current max, then we can jump. So if we've reached that point, so next time we loop through it, and we come here, the current max is going to be this one, and so it's just a mechanism to make sure we move to the array. So at in the beginning, and what we can do is if you get a max value, then we could say uh, current current max is equal to max. So what we do is we'll come here, current max is going to be 2. We'll say, okay, max is going to be 2. And then we increment there. Then we come here, current max is equal to 3. Current max at 3. So that's going to turn to I plus 1. That's going to be 4. So it's going to take us here. But we're going to loop through here and we'll say, okay, current max is for this one is 4, but I have to show I have just the jump variable here. So the first time so from here, when current max moves to there, that's just going to be one jump. So jump is going to be equal to 1, and we move it to 2. Next time we come here, so current max is going to be 4, but I is not equal. So when we come here for I to this, so current max is going to cross over, it's going to jump to 4, and jump is going to be equal to 2, and uh, and will basically be end of it. So next time we come here, it's going to be 1 and it's going to take over. But for this example, we'll be at the end. Similarly, if we look at this example, uh, we could uh, we could do it this way as well. So initially, current max is just going to be here. So it's going to be it's going to start at 2. We'll move it there, uh, and become here. Max is going to be 4. Jump is initially it's going to be from 0, then 1, and then we come here and it's going to current max is at 0, but it doesn't really matter because we already calculated from for 3 that the max is going to be 4. So we'll do 2 and the current max will be at the end of it, and we can just loop through it, and it wouldn't affect our jump, so we'll be able to do it. So let's just run this code and see if this works. Okay, if it does, then we go in there. LNGTH. So we got the test cases done. Let's just submit this and see if there are any edge cases. And we're able to solve it.